Welcome back. At this point, you should have a basic understanding of the RStudio development environment, and we should be ready to really get into some R coding. What I'd like to do in this video is to go through at kind of a whirlwind pace a entire data analysis process, and this is just to get you to understand quickly how cool the kind of cool things we can do really quickly. And it's also a screen so that we don't throw you right into the kind of boring nitty-gritty stuff, which we will get into right after this video. So just want to make sure that you know where we're going and how cool it will get very quickly. But we do need to go through data types and data storage objects and kind of dry stuff, but it's going to be critical. But first, after we get through, so this is the R script that you should have already downloaded and loaded up into RStudio. This is for Bootcamp 1, Module 1, and it starts off with a bunch of comments. Everything with a # preceding is a comment. R doesn't care about those things, but it just tells us what this module is all about. And what we're going to do now is to start off where it says R demo, and this is where we're going to just give you a taste of all the stuff we're going to do later in this boot camp. Don't worry if you don't understand everything, that's fine. We'll get into much more detail on all of this later. This is just a taste. So the first thing to notice here is this first line that is not commented out here is just a straight command to this data function. So the function is enclosed in parentheses, and we say this is the argument to the function. We'll talk more about functions, but we're going to basically, this is saying extract the trees data set, which is built into R. So every one of you, because you downloaded R, has a whole bunch of data sets just accessible to you, and you can just access this. Once I run this line, it should load something up in my environment, and there's a data set called trees that is now loaded in my workspace or global environment, and I can work with this data set now. So this is just a way to quickly play around with different types of data sets without having to find and load up a data set. They're just built in to R. So if you want, you could add a comment to this line and just say load built-in trees dataset. And I do encourage you to go ahead and comment out the code to make sure it is understandable to you. And everyone has a different commenting style. Use whatever makes sense to you. So load built-in trees dataset here, and let's look at this object. So there are some useful functions in R that allow you to explore data objects. So let's just kind of look at what's in this trees object. Again, we're going to call a function. Anytime you see a command that has a parentheses in it, you're probably calling a function. That's the way R's function interface basically works. So at any time you see something that has the structure, some function with parenthesis, you're calling a specific function which has, it's basically going to do whatever that function is supposed to do and return whatever that is supposed to return. It is very general. We'll talk a lot more about that. But this summary function takes a data set and it returns what's in the data set. So this data set happens to have 3 types of data in it, 3 columns. If you think of this as like an Excel data sheet, 3 columns of data. One column is the girth of a bunch of trees. One is the height, and one is the volume. We can use this str for structure function if we want to get some other information about this. So the structure function now tells us that we are working with a data frame. A data frame we'll see is the primary data storage object type in R. And this data frame has 31 observations, or 31 rows, if we like to think of it as an Excel data sheet, with 3 variables. And those variables are girth, height, and volume. You can see that here as well, girth, height, and volume. And that's all we'll do for now. There's a lot of other ways you can explore your data set, but already we have some idea what's in this data set. Another one, let's see, another one we could do is just this head trees. If you use this head function, it just types out or prints out the first few rows of the data. That can be useful as well. We'll use that a lot. So this just gives us by default the first 6 observations in the trees data set. And one more thing that we could do is if we use this question mark. The question mark is a shorthand for I want help on. Another way to do that is just to type in help trees. That's the same as typing question mark trees. We can get some more information about the data set. So that's kind of a useful thing as well. So R will just tell us about this built-in data set, provides measurement on the diameter, height, and volume of timber in 31 felled black cherry trees. So feel free to go on and read more about this data set. It's kind of a useful, simple data set to get you started with data visualization, analysis, etc. in R. So let's do some more with this. There's a few functions that will be really useful in just visualizing the relationships that might be in this data set. So let's look at this. First of all, we're going to use this layout function, which helps to prepare a graphics window that will allow us to have multiple panels side by side, which is a really useful thing. So, and we'll talk more about that later, but you'll see it doesn't look like it does anything, but then once we run the next few lines, you'll see that you have this multi-panel graphics device that allows you to put panels side by side and makes it look nice. So let's run this hist function. The hist function is short for histogram, and this just gives us a histogram of the data. So it describes this, in this case, the height data, and you can see that the minimum height of the trees is about 60. We could learn more about what the height actually is in terms of, it's in feet. So if you look at the help file, you can figure out more about the data. So obviously you want to know the units. Let's go back to the plot. So they range from 60 feet to about 90 feet with the most common values somewhere between 70 and 80 feet. So that's cool. Let's add another histogram to this multi-panel figure. This is the girth. This time we see that the girth ranges from a low of around 8 inches. There we go. So this is the tree diameter in inches. And so if we go back there, the girth ranges from 8 to about 20, with a majority in the order of 10, 12, 13, so on. Let's add the final one. This is tree volume, and the volume is in units of cubic feet. So if we go back there, we can again just get a really quick and dirty description of what's in this data set. All right. Let's do another data exploration. And this is just following the standard way that data analyses are done. You first load a data set, you explore it, you visualize it, you maybe look for some relationships just visually, and then you start running some analyses. You make some, you might test how well the analysis works. If you're doing a predictive model, you want to test, how good those predictions really were. You might want to validate it with independent data and so on and so forth. And then you end by, maybe making some nice visualizations of the results of your analyses. And that's what's called a data workflow or an analysis workflow. And R does all aspects of the workflow. So you can basically, in a single script, you can go from entering data to visualizing, exploring data, to doing analysis, to doing modeling, to making nice figures. So R is kind of like an environment that does every single part of the data science enterprise. It just does, and it does it well. All right, so let's make some scatter plots. That's another nice visualization that we can do. So we're going to set the graphics device to have 2 panels, and let's plot volume against girth and volume against height. And we can already see that there are some interesting relationships just by looking at the scatter plot. Clearly, trees that have higher diameter have more volume. That kind of makes sense, but it's nice to see it anyway. And taller trees tend to have more volume as well. And you can see how the relationships look. So there might be some information here. We might want to go further. We might want to actually model those relationships. We might want to be able to develop an equation that describes volume as a function of girth and height. So those are the kind of things that we might want to do next. Another useful function that R provides us is this pairs function, and this just automatically provides scatter plots of all variables against all other variables in our data set. In this case, we have 3 variables: girth, height, and volume. And this pairs function is just a convenience function, so we don't have to write out the scatter plot, separately for every single possible relationship. We see girth versus height, girth versus volume, height versus volume, and so on and so forth. So just a nice, easy way to look at relationships in your data set, which is kind of cool. Next thing we might want to do in our workflow is to actually do a more quantitative model. We would actually run an analysis and fit a relationship between, say, volume and girth. And we can do that relatively easily using this basic statistical function in R called LM, which is short for linear model. This is going to be a standard ordinary linear regression model. And we're going to use this formula interface that you'll see again and again every time you work with regression type models, or just building models of some response variable as a function of a bunch of predictor variables. You're always going to see this type of type of syntax, and you'll see this squiggly or tilde, and that represents, you can kind of read it as a function of. So I'm going to model volume as a function of girth, and I'm going to feed it the trees data, which we have been exploring. And so this is just going to make a linear regression line or model that defines volume as the response as a function of girth. And let's just run it. So if we Control Enter and run this line, we'll have the model, and you can see the model is now an object in our global environment. We assigned whatever the results of this function were, we assigned that to this object called model 1. All right, and that model 1 is here. So if we want to look at model 1, we can use the summary function, which we've already seen when applied to a data frame, but it does something very different when applied to model 1. So let's look at that. Summary function is just a very flexible function that does different things depending on what kind of object you give it. If you give it a model object, it gives you something that looks like this, which is very useful because it gives us all these kind of summary statistics about our model. It first tells us what the model was that we called. It gives us a summary of the residuals from the model. It gives us the coefficients, which is often what we're really interested in, is we want to know this relationship. We want to know the intercept, but we also even more want to know something about the slope relationship in a linear regression between the response and the predictor variable. In this case, girth does have a significant, this is the p-value. If the p-value is below your cutoff, this time it's below any reasonable cutoff. And so, girth is an important predictor of volume in this case. And it gives you an overall p-value for the whole regression model. If you're doing a multiple regression, that is important to look at. It gives you an adjusted R-squared. In an R-squared, this case, the R-squared is 0.935, which is really, really good. That is, most of the variation in volume is explained by diameter, which is probably intuitive, but kind of cool. All right, so are we done? Well, not really, because we want to maybe go a little farther and just show what this relationship actually looks like. So let's visualize the results and visualize the predicted volume across a whole range of diameters. So the way to do that, what we're going to do is first set a range of diameters, of tree diameters that we want to make predictions about volume for, and that's what this xVals is going to be. That's going to define the values of girth that we're going to make predictions for. And then we're going to actually make predictions. We're going to use this predict function, which is a generic function in R that helps us make predictions from any types of models, not necessarily a linear regression, could be a non-linear regression, could be a machine learning approach. We give the predict function the model that we want to make predictions from, and we give it a data set that includes all the values for the predictor variables that we want to make predictions for. So we're going to make a predicted response for a whole set of different predictor variables. In this case, it's just a range of girth values. So we're also going to give the predict function, we're going to tell it we want to not just the prediction, but we want a predicted confidence interval. Because just a point value isn't really enough when we're doing statistics. We need to inform our readers how uncertain or certain we are about the predictions we're making. So that's another key component. So we're going to include a confidence interval, and we're going to do the confidence interval at a alpha level of 0.99, and we're going to do a 99% confidence interval around our predictions. So if we control enter that, or command enter, we're going to have a set of predictions. If you want to look at the predictions, we just called whatever the predict function returned, we're saving it as an object in our workspace called pred. Now, if we want to look at pred in more detail, we could type out pred here, and we see that what pred gives us is a whole set of numbers. The first column of numbers is called fit, and that's going to be the predicted value, the predicted volume for a given girth value. But we also have a lower and upper bound for our confidence interval. So that's pretty cool. So we have a prediction plus the uncertainty bounds on that prediction, and we have those predictions across this whole range of girth values. So one thing that would be really cool to do is to put that on a plot and plot out not just the predictions, but plot out the uncertainty around those predictions. And that's a great way to communicate what we know and what we don't know to other scientists, managers, stakeholders, whoever we are wanting to communicate our results to. And so let's take those predictions and plot them out. The first thing we're going to do is, actually the first thing we should do is let's reset the graphics window. And one way to do that is just to say graphics off. And that just shuts down the graphics window. If you have multi-panel figure set up, it's not going to be multi-panel anymore. It just goes back to the defaults. So if I do that, it gets rid of the plot and allows us to start fresh. All right. And let's run this line, and that's going to basically plot out our scatter plot of volume and girth. But I did a couple things here. I made it look nice by adding a plot title, adding an x-axis and a y-axis label and an x-axis label. And I added units. So this is becoming a nicer, more high quality, more readable figure. Let's add a line. This line is going to represent the regression line that we just fitted when we used the LM function above. So we're going to take this model 1 and we're going to feed it into the AB line function, which adds lines to an existing plot. And we're going to add, by putting this model in this function, we're going to add the regression line. And we're going to make the regression line green. So we're going to use this modifier, this argument to the AB line function. We're going to make it a thick line. So the line width, or LWD, is going to be 2, which is fairly thick. So we're going to add a thick green line into our plot, and that's our regression line. But we're not done, because we need to add and uncertainty bounds. We need to add confidence intervals around our prediction. So we're going to use this lines function, and we're going to take our predicted upper bound and predicted lower bound and just add it onto our figure. The lines function just adds a line onto an existing figure. We're going to make them green as well, but we're going to make the line type not a solid line. We're going to make it a dashed line by saying line type equals 2. So let's add the upper bound. There it is. And we add a lower bound. And those are our confidence intervals around our regression line. So that regression line really could be anywhere. This is our fitted regression line, but the line could be anything that fits within these confidence bounds. And that communicates uncertainty about our regression line. We can even add the full equation onto our figure if we want. So it doesn't look perfect here. If you want to see the figure even more closely, you can hit the zoom button and it gives you a better idea of what the figure looks like. You could actually expand it, make it even bigger if that helps. So there's your figure. I think I had one more component to it. I added perhaps a p-value. Yep. So you can use this text function to add text to an existing figure. So this is where we basically end with this whirlwind demo, but this kind of takes us through a data science workflow, all the way from loading in the data, visualizing data, exploring the relationships, running a model, and visualizing the results from the model. It's a really simple example, but hopefully it gives you a flavor of where we're going and what R can do. In the next video, we'll start getting into the dry stuff, talking about the data objects and how to access data within objects and so on and so forth, all the different data types that we work with. So we will get to that in the next video, and I will see you there.